So the quiz is all about the formula that you see that they've asked about in problem number 1. Do you guys remember what the formula is for the derivative?
As the limit approaches 0, you don't have to do the limit crowd. Oh wait, limit approaches 0, f times a plus h, x plus h, minus f of x over h.
Okay, so if you don't know that formula, not only will you miss problem number 1, but you will not be able to do any of the ones below. So the first thing you have to do is make sure you know that the derivative is given by that little prime thing right there, is just the limit as h approaches 0 of f of x plus h minus f of x over h. Now we're not going to do the a ones because we are not finding the derivative at a particular number. We are just finding the general derivative in terms of x. So that's why we're going to use the x version, okay? So that's the first question on the test. You should know that. Now, what does the derivative tell us? It tells us the slopes of the tangent lines. So throughout the rest of this course, you always have to remember that the derivative is a representation for the slope of the tangent line or an instantaneous rate of change. So that's the main thing you want to remember. Derivative is slope of the tangent. Derivative is slope of the tangent. Okay. So now that we've talked about that, we have these 4 that we're going to find the derivatives of. Tomorrow you have 4. You will have it kind of in the similar order. You're going to have 2 classic polynomials, a square root and a fraction, okay? So your first one here, number 3, says to find the derivative. So remember, we're going to take the limit as h approaches 0. We're going to stick x plus h into the function. So it's not a bad idea to write underneath the function what happens when I plug in x plus h. Well, that's 6x plus 6h minus 2. If you do that ahead of time, you are prepared then to write down the f of x plus h version right there in the formula. So we're going to write 6x plus 6h minus 2. Now we are going to minus off f of x. So put that in parentheses. So you remember to subtract all the pieces, okay? So the next step you're going to take is you are going to actually distribute that negative. So we're going to have 6x plus 6h minus 2 minus 6x plus 2. Now, if you did it right, at this point, everything that does not contain an h should cancel out. Everything that does not contain an h should cancel out. So you will notice we have a positive 6x, we have a negative. We have a negative 2, we have a positive 2. So like I said, everything that did not have an h in it will cancel out because we are left with only the 6h. When we divide that by h, at this point, you should be able to divide off the h that's in our denominator. You get 6, and the limit of a constant is just that constant. So the answer for the first one is 6. Okay. Does anyone have any questions on how we calculated our first derivative? That one's good. Huh? Yeah, those ones are good. Okay. So now we've got our first one here. I'm just going to make it a little smaller so I have room for the next one. So let's now do number 4. Now number 4, to plug in x plus h is a little more complicated. So let's do that first. Let's get that ready. When you square x plus h, please remember that that is x plus h times x plus h. You are going to have to FOIL, factor, distribute, whatever you want to call that. So when you do that, you get x squared. You'll have an xh plus another xh. That's why you have two xh's plus h squared. And then that 1, don't forget, is taken on the back. So now we have calculated x plus h. Now it's time to apply the formula. Okay. So the derivative is going to be the limit as h approaches 0. We're going to write down f of x plus h, which we found to be x squared plus 2xh plus h squared plus 1. And then we're going to minus, in parentheses, the original formula, all over h. Does everyone understand where we're at so far? Now the next step you're going to do is you're going to distribute in this negative here to both of those pieces. So we get the limit as h approaches 0 of x squared plus 2xh plus h squared plus 1 minus x squared minus 1 all over h. Now at this point, anything that does not contain an h should cancel out. So since there's an x squared that doesn't have an h on it, there should be a negative x squared in your problem. We have a positive 1, we have a negative 1. Everything else in the problem contains an h. So you should have 2xh plus h squared divided by h. Now remember, that means that the h goes into every single term in the top. So we're going to divide that into every single term. And so we get the limit as h approaches 0. If we divide the first piece by h, we get 2x. The second piece by h divided by h squared divided by h is just an h. And then we're substituting in an h value of 0. So it would be 2x plus 0, or our answer is 2x. So you should get an answer with just x's in it when you're all done, because your h's should substitute 0. Okay. So that is number 4. Anybody have any questions about what happened to number 4? Okay, I'm going to make that littler so I can fit it. Okay, so there's number 4. So now we're moving on to some more difficult stuff because we have square roots. Now, square roots are going to be fixed using a conjugate. So let me remind you how to do that. So the first thing we're going to do is we're going to plug in x plus h. And it doesn't do much. It's just the square root of x plus h plus 1. I don't know what that is. It's just that square root. Okay. So now let's apply the formula. We get the limit as h approaches 0 of f of x plus h, which is just that square root, that funky square root, the square root of x plus h plus 1, minus our original function, square root of x plus 1, all over h. Now, right now, there is really no mathematics we can do to fix the problem without using a conjugate. Okay. So let me show you what to do. Surround your top by a parenthesis, and we are going to put the conjugate on the outside of the top and the bottom as a multiplication, because if you have something that's fractional, if you multiply something by the top and the bottom, that same something, you don't change the value of that fraction, so we don't hurt the fraction. So we're just going to do the square root of x plus h plus 1 plus the square root of x plus 1. You'll notice the only thing that changed is this sign. Everything else is exactly the same, okay? And then whatever we multiply to the top, so we don't mess up our fraction, we do to the bottom. Now remember, in the last problems, we were able to divide off the h. Our goal in all of these problems is to be able to divide off the h. So The h just needs to sit there in the bottom until we're ready to get rid of it, okay? So the bottom just rewrite. Okay, don't do anything to the bottom, just leave it alone. Okay. Now, here's what's great about the top, okay? Technically, that's really just an a minus b times an a plus b, which is really going to become a squared minus b squared. It ends up being the difference of squares. So what happens when you square square root? Square root pops off of it, okay? So what's great about these two being conjugates is those two multiply together and give you the square of what we originally had. Those two multiply together and give us the square of what we originally have. That second piece, just you're subtracting that square. So when you subtract that square, keep it in parentheses. That being said, we are going to get the first term squared, so that square root popped off, minus the last term squared. So that square root popped off, but just so that things will work out correctly, keep it in parentheses so you remember that we always need to distribute that minus. Okay, so is everybody with me at this point? Now, at this point, we're going to do just like we did for polynomials. We're ready to distribute, get a list of things. Everything that does not contain an h will cancel out. Okay. So we get the limit as h approaches 0 of x plus h plus 1 minus x minus 1 all over that gross denominator. Okay, now watch what happened. The x doesn't have an h, but it has something to cancel it. The 1 doesn't have an h, but it has something to cancel it. So we are left with h over h times that gross thing. Now, what's going to happen here now is we're going to divide h by h. H divided by h is going to just leave a little 1 in that spot. So we're going to have the limit as h approaches 0 of 1 over that disgusting thing. Okay. Now, the only variable we have to plug in is a value of 0 for the h's. The only thing, the h is going to become 0. And then we got it. So it's 1 over the square root of x plus 1 plus the square root of x plus 1s. How many square root of x plus 1s do we have? 2. So our final answer will be 1 over 2 of those things. Okay. So that is number 5. The square roots will always work exactly like what you've just seen here. So follow that, and then you're ready to go. Follow that, and then you're ready to go. Okay, so the last one we're going to do is probably the most difficult. The fraction ones are always the most difficult. Let's go over the procedure. Under the fraction, just like we've been doing in the past, write down what f of x plus h is so we have it as a resource. So that's going to be 1 over x plus h plus 1. I don't know what that is. It's just a fraction. Similar to our square root, it doesn't reduce, it doesn't do anything nice. It's just kind of this thing. Okay. So remember what our derivative is. It is the limit as h approaches 0 of f of x plus h minus f of x all over h. Now I've just set it up. Now here's what you want to do every single time we have a fractional one, okay? This procedure will work every single time. Yeah. Why? Okay, so put parentheses around our denominator. Put parentheses around our denominators. Remember the formula, f of x plus h minus f of x over h. So I've just set f of x plus h, f of x all over h. Okay, so I've just set those into my formula. Okay, so it always creates this kind of compound fraction, a fraction within a fraction. Okay, now here's what you're going to do to fix it. You're going to put, let's put a big old bracket around the top, parenthesis around the bottom. Okay, whatever these denominators are, we need to get rid of. So we do that by multiplying here by x plus h plus 1 and x plus 1, and here times x plus h plus 1 times x plus 1. So all I've done is I wrote these two denominators to multiply on top and bottom over there. It's just these two denominators written over here on the side. Okay. Now here's why we do that. We do that so when we distribute and they're sitting up on the tops, some good things will cancel. That's what we're hoping to do. Okay. Now, watch where we want to go next. You always just write next the big old list of what was in your denominator. Just like our square root 1 when I said don't multiply, it's not going to help you. I'm just writing down this list. I've not done any math. I've just listed what was in our denominator, okay? Here's the math. We need to actually physically multiply this by each fraction. To multiply something that is not a fraction by something that is a fraction, it only multiplies on the top. So what's happening is here, this multiplies just on the top. What cancels? Yes. What's left? X plus 1. Okay. Now let's do it again. This multiplies here. What cancels? What cancels? X plus 1. What's left? X plus h plus 1. Now keep the minus there. And look, it immediately becomes a nicer problem because we know what to do now, right? Okay. So again, okay, let me show you again. So this only multiplies on the top, and then x plus h plus 1 cancels. So we are only left with an x plus 1. This multiplies here. The whole thing. No, you do the whole thing each time because it's distributing. Okay. And then this multiplies here, and this time the x plus 1s cancel. So that's why that's left. Okay. Now let's do our distribution so we have our string of things so we can cancel some junk out. We're left with x plus 1 minus x minus h minus 1. Now remember, everything that does not have an h should cancel out. The x's cancel. The 1's cancel. What's left? Negative h. Awesome. Okay. So we found out that there's only a negative h that cancels, or that's up there. So now we should always get to the point once we've simplified that numerator that we should have some kind of h sitting there so that our h in the bottom can cancel out. That's our goal, remember? Get that h in the bottom to cancel out. So watch. H goes into negative h and leaves what behind? A negative 1. So we're almost done. So we have the limit as h approaches 0 of negative 1 over x plus h plus 1 and x plus 1. Okay. We can put in 0. It's allowed. It doesn't mess up the fraction, where the only variable that becomes a 0 is the h. So we end up with negative 1 over x plus 1 times x plus 1. Or I like, if you left it there, full credit, you're fine. But I like -1 over x plus 1 squared. So that is your derivative for that one.
I know what I'm doing now.
Good. It's a matter of seeing those patterns. And those patterns will start to kind of just, you'll recognize them, okay? So on the quiz, you will have 2 polynomials, a square root, and a fraction, just like you see here, okay? You also have to answer questions 1 and 2 on the quiz. The last thing that's on the quiz is number 7, okay? Okay, let's talk about number 7 for a minute. Using number 4, can somebody tell me what was the derivative we found for number 4? So I can write it here. What was the derivative? 2x. Okay. Now, I'm going to also write my equation so we have it. Okay. Okay. So it says, using number 4, find the following. Now, what do we know? We know that f of x is x squared plus 1. We know that the derivative is 2x. What is the point when x is equal to 1? What do you use? You use the actual function, right? And so to answer number 7a, we're just going to plug 1 into the original function. So we're going to get 1 squared plus 1 or 2. So the point is 1, 2. So on the original function at x equals 1, we are at the point 1, 2. Now, B says find the slope when x is equal to 1. So which, the slope of the tangent when x is equal to 1. What formula gives us the slope of the tangent? The derivative, the 2x. And so now we're just going to do the derivative at 1. So you just plug in 2 times 1 or 2. So the slope of our tangent is 2. So the derivative gives you the slope of the tangent. The original function gives you the point where we're going to hit that particular slope. Now, part C says, what is the equation of the tangent line at x equals 1? Yes. That means it's the slope of the tangent. M of t is the slope of the tangent. So your equation of the tangent line is always going to be y minus y1 equals m times x minus x1. And we can put a little t there. So what are we going to use? We're going to use the point we found in A. We're going to use the slope we found in B to find the equation of the tangent line for C. So it's just going to be y minus 2 equals 2 times the quantity of x minus 1. That's it. Now, make it prettier, but otherwise, we know the equation of the line. There it is. And so we get y minus 2 equals 2x minus 2. Add 2 to both sides. Y equals 2x. Okay? So this is what your quiz looks like. Hopefully now, if you were stuck on any of the 3-2 homework, this probably is hopefully cleared up the ones you might have been stuck on. You have the remainder of class to work on your 3-2 homework. So, and also if you haven't done your 3-1 homework, that was due yesterday. Your 3-2 homework, I think, is either due tonight or tomorrow. Quiz is tomorrow. It's going to look just like what you see here.